This is section 11.5, alternating series. So for the alternating series test, we're looking at a power series that has a negative 1 to the n exponent, or n minus 1 exponent. We need to just focus on b sub n. And if we can show that these two conditions are met, then we can conclude that the series is convergent. So we first need to show that the b sub n is decreasing. That's what this means. And then we can show that the limit is equal to 0. Then that will tell us that the series converges. So for this first example, we need to write this in power series form. Notice that the top is always 2. The bottom is increasing by 2 each time. So that's an arithmetic sequence. So an arithmetic sequence can be written in this form. The first term is, we're just focusing on the denominators, not the numerators. So the first term is 3. And the common difference is 2 because these numbers are increasing by 2 each time. If you distribute and simplify, you're going to get a sub n is equal to 2n plus 5. And so the power series can be written as n equals 1 to infinity of 2 over 2n plus, oh, I'm sorry, this is a minus. So that's not a 5. That would be a 1. All right, so then we have the negative 1 to the, looks like the first term is positive, so therefore we want this to be n plus 1, because if you plug in 1, that would make it 2, which would make the first term positive, which is exactly what we need. All right, so there it is. So this is our b sub n. B sub n is equal to 2 over 2n plus 1. This is clearly decreasing, so we can say that b sub n is decreasing because as n increases, these get smaller and smaller. B sub n gets smaller and smaller each time as n gets larger. And now we just need to show that the limit as n approaches infinity of b sub n, well, as n gets large and larger, this is going to go to infinity, which means the whole fraction is going to approach 0. Thus, the series is convergent by the alternating series test. Alternating series test. That's what you can say. I'm abbreviating. You can do the same thing. All right, so for this next example, we still have a power series with the alternating sign. So that's kind of the giveaway. Whenever you see a negative 1, kind of gives it away that you're most likely going to be using the alternating series test. So b sub n is going to be 1 over radical n plus 1. In this case, it's very clear that b sub n is decreasing as well, because as n gets larger and larger, this is going to get smaller and smaller. So we can just say that b sub n is decreasing. So now we go to the limit as n approaches infinity of 1 over radical n plus 1. Well, that's clearly 0 as well. Thus, the series is convergent by the alternating series test again. All right, let's move on to the next example. All right, this one I'm going to rewrite in this form, or never mind, I'm just going to go ahead and call b sub n is going to be n over e to the n. All right, in this case, it's not so clear that it's decreasing, but it is decreasing for n greater than 1, I believe. Greater than or equal to 1, because these terms get larger faster than these do. So whenever these get larger faster than these, then that means that the fraction is going to decrease. But to verify, you can also do the first derivative test. All right, so if you do the first derivative test, it's going to be e to the negative n plus, that's going to be e to the negative n times negative 1 times n. So that would be a negative. and we got to check when it's less than 0. So that's going to be, so it's going to, whoops, yeah, that was right. So by the first derivative test, this is going to decrease when for any values where n is greater than 1. So I did the first derivative test. I took the first derivative using the product rule, and I set it less than 0 because that means it's decreasing. That's going to show you the values for which it's decreasing, and it turns out to be decreasing whenever n is greater than 1, which is perfect because n is going from 1 to infinity. So we've established that b sub n is decreasing. All right, now we need to just show that the limit is equal to 0. We're going to have to use L'Hopital's rule in this case. So L'Hopital's rule is when you take the derivative of the numerator and the denominator, and the derivative of n is 1. The derivative of e to the n is e to the n. And as n approaches infinity, this approaches 0. So thus, the series is convergent by the alternating series test. All right. Well, for this next one, notice that you have cosine of n pi. If you plug in 1 for n, that's cosine of pi, which is negative 1. If you plug in 2 for n, that's 2 pi, which is positive 1 for n. So this is just going to alternate back and forth between negative 1, positive 1, negative 1, positive 1. So I'm going to rewrite this in this form, which is going to be equivalent. We just got to make sure that the first term is, if you plug in 1, that's 1 pi. Cosine of pi is negative, so we want the first term to be negative. So therefore, you would just put an n. That would make the first term negative. All right, so now we have this, that it's in a nicer form for us to consider for an alternating series test. So let's let b sub n equal n over 2 to the n. Once again, you're probably going to have to do the first derivative to verify that this is decreasing. But if you do the first derivative test, you will see that it is, because this the denominator is growing faster than the numerator. So let's just do the first derivative test. That's going to look like this. Let's see, n 2 to the negative n. First derivative will look like, let's see, that's going to be, I'm just going to write it out for you. It's going to be n parentheses negative 2 to the negative n ln of 2, close parentheses, plus 2 to the negative n. All right, and we need that to be less than 0. So if you factor out the negative 2 to the n, or just a positive 2 to the negative n, you should get, let's see, that's going to be 1 minus n ln 2 less than 0. And that means that it's going to be decreasing for all the values when n is greater than 1 over ln 2. Because this will always be positive, so we only need to consider this part. So you set that less than or equal less than 0, and if you solve for n, you get this. So yeah, so it's going to be decreasing for whenever n is greater than this number. And so therefore we can just say b sub n is decreasing. Now we take the limit as n approaches infinity of n over 2 to the n. Once again, we have to use L'Hopital's rule. The derivative of the numerator is 1. The derivative of the denominator is 2 to the n ln of 2. And this clearly approaches 0 because the denominator is going to go to infinity. So therefore, this is going to approach 0. Thus, the series is convergent by the alternating series test. And that